Okay, so in the last class we were talking about inverse functions, and then we tried doing some problem and we got stuck, and there was one reason because of which we were having issues in identifying which answer is correct. That is because every inverse function that we talk about is constrained by inverse trigonometric function that we talk about is constrained by the range of value that we should that is acceptable for them. So we'll come to that and we'll try doing that. If maybe today, if not today, then maybe in the next class. What happened? Tony is joining, disconnecting. Okay, Tony is back. All right. So today I wanted to make a fresh start. So we will go back to inverse function if time permits. But today we want to talk about law of sines and law of cosines. And this is a very interesting topic. So before I start talking about it, let me check who all has come across this concept of law of sine and law of cosine. What does it mean? How does it help? Any idea, any thoughts? Trini took no time to say no, you are good to get started. How about Samriddhi, Dheera and Tony? Have you guys come across something called law of sines or law of cosines?
I don't think so.
Okay, that's a good news. How about Dheera?
Yeah, I don't know. I don't think so.
Oh, okay, that's fine. So that gives me, okay, how about Tony? Law of sines and law of cosines. Have you guys heard this term before?
No.
No? Okay, that's a great news for me as a teacher. I can take pride in the fact that I'm teaching you as something that is new for everybody. Okay, I see some kids coming in. So I will give 30 more seconds and then we'll get started. Come on in, come on in, come on in. Okay, so now you guys have a responsibility of helping me with the closing of the garage door. Yeah. Okay, so I was asking a very stupid question to the kids, that have you guys come across the terms law of sines and law of cosines, and what does it do? Any idea? Wonderful. That makes you super happy now. That I'm starting something that will be a learning experience for you guys as long as I don't do a bad job. Now, so far, if we talk about trigonometry, again, law of sines and cosines, it relates to the concepts around trigonometry. Keep your phones away, everybody please. Okay? So that I have your undivided attention. Okay? So, we are talking about law of sines and cosines, and that relates to trigonometry. So, our trigonometry journey starts from a right angle triangle. Yeah? So, Katoa, all of you know. And we also see that, okay, it's a right angle triangle where we also know about the Pythagorean theorem. You know two sides, you can find the third side. So far, easy peasy. Now, is trigonometry all about right angle triangle? No. Because we saw that in unit circle also, where you can go about angles which is more than 120, 190, 450, 1025, whatever you want to. Okay? So that essentially means you are going beyond a right angle triangle. But here the limitation is you have two sides known, you can find the third side with a right angle triangle. If we also learned about the basic values of trig functions, sine 30, sine 45, sine 60, sine 90, what are. Is everybody very clear about those numbers? The value of trig functions? Pranit is clear. Dheera, Samriddhi. Okay, I'll assume for now. We'll come back to it any which way. So, this is okay. Now, let's add more color to what we know. We have a triangle now, which is not a right angle triangle. This is ABC, Maybe I know about this angle. Let's say this is 45 degree. This angle may be 60 degree. We can find the third angle. If I know this side is 12 centimeter, if I leave you guys here, here. If I leave you guys here, you have a triangle which is not a right angle triangle. You know two of the angles, you can find out what is the third angle. You know one of the side. Can you find other two sides? And the answer would be no, because this is what we know about right angle triangle. You know two sides, you can find the third side. You know if you know one angle, you can find the other angle and you can find out sine cos tan.
Can't you just draw a perpendicular line in the middle?
I can draw a perpendicular line in the middle, but what will that do?
Because you can just use the bottom two angles to figure out the middle angle, and then once you bisect it in the middle perpendicularly, then you got those, and you can use those to get the other
I'm
side.
not bisecting it. It may not be a perfect bisecting also.
Well, then you have the 90 degree on both sides, so you can still get the top degrees.
You can get the degrees, okay, fine, I get that. You get the angle. How about this side's length?
Well, then since you have 90 degree angles, can't you just like?
You have 90 degree angle, you don't know the height yet. And I'm loving that conversation.
Then you can use SOHCAHTOA.
You cannot. SOHCAHTOA will tell you, okay.
Wait, SOHCAHTOA only for 30, 60, 90 and...
Yeah, how about this being 42 degrees? Okay, so let me not, yeah, Sahib, you're saying something. Go ahead.
For the small triangle, can't you use 30, 60, 90 triangle?
Yeah, the
30, 60, 90 would be okay. As long as we know the familiar angles, we are fine. Our problem is, or let me not take you guys in the wrong direction. Let me first say that, let me first tell you guys what is the law of sine, law of cosine, and then we will come back to this concept, okay? If you have a triangle, let's say, this is A, angle A, let's say alpha, this is beta, and this is gamma, okay? Okay? Three angles. Everybody with me, right? So far, I'm not going way too fast. I have a triangle, which is not a right angle triangle, okay? I'm giving you guys the assurance that this is not right angle triangle. This is probably a scalene triangle, okay? Or a acute angle triangle. And I have this side as A, this side as B, and this side as C. If I know three angles of a triangle, and I have three sides, there is a law of sine which says sine alpha, let's say, divided by the side opposite to that, equal to sine of beta, second angle of the triangle, divided by the side opposite to that, will be equal to sine of gamma, the third angle, divided by C, the third side. So law of sine says that there is a relationship between your sides and the sine of the angle, and they are in the same proportion. So law of sine says any angle, sine of that angle divided by the side opposite to that is in the same proportion. So pick any angle, take a sine of that, divide that by the opposite side, is equal to, take the second angle, get a sine of that, divide by the second side opposite to that, is equal to the third angle, sine of that, divided by the third side. This is law of sine. Okay. Now, how does it help? How does it help is, let's say you have, in this case, you have two sides, you can find the third side. Maybe you can find out the theta also, I mean using the tables. But here in this case what's happening is, if you know just one angle and two sides, you can find the other sides, all the sides. Or if you know two sides and one of the angle, you can find other angles also. Think about this. You know just these two sides and one of the angle. let's say this is not a right angle triangle. This is a triangle, you know just this angle and this side, and you know this side. If you have a situation like this, if it's not a right angle triangle, you by no means you can find out the third side, because third side you can find out using Pythagorean theorem when you are talking about right angle triangle. This is not a right angle triangle. So here there are two things that it tells you. One is there is a relationship between the sine and the side opposite to that. That is one. And second thing is, it is such a generic concept that it can be applied for any type of triangle. Am I being able to make some sense so far? Yeah? So this is law of sine. This is law of sine. This says this. Now, the next question is why? Why would you guys believe somebody who is just blabbering? Samriddhi, Praneeth, would you believe just because I'm saying so, or you would want me to prove? No, I'm saying this is the law of sine, which says if you have any triangle, regardless of the type, acute angle triangle, obtuse angle triangle, scalene, isosceles triangle, right angle triangle, doesn't matter. Every kind of triangle, it says that the sine of the angle and the side opposite to that is in the same proportion. You pick an angle, get a sine of that, divide that by the side opposite to that, will be equal to, pick the second angle, get the sine of it, divide by the side opposite to that. These proportions will be the same. So basically it tells you that there is a relationship between the angle and the side.
Oh yeah, because the biggest angle is related to this, is opposing from the longest side.
Right.
And then so on to the shortest angle.
So that's a intuitive view of it. Now we are getting more mathematical about it. We are saying how. So now this is the law of sine. Okay. Now this is not a law written in the law book which you guys have to just blindly follow. It's a math problem, and we have to see how is that to be believed. Let's decode it. Praneeth, you were saying something? You would want. I'm sorry?
When you asked if you wanted to prove it, I said prove.
Yeah. You must challenge your teacher that don't tell us something that we should follow blindly. Now let's look at it. So guys, everybody here. I'm picking up a triangle randomly. Okay? I picked up a triangle randomly where everybody is confident, convinced that this is not a right angle triangle. Yeah? This angle is much bigger than 90 degrees. I picked up a triangle A, B, and C. Everybody can see the board? Dheera, Samriddhi, Praneeth, everybody okay? Now, so this angle, let's say this is alpha. This angle I am calling as beta, and this angle I am calling as gamma. Okay. You can call Praneeth, Samriddhi, Dheera, Ayush, Daivik, Sahit, whatever you want to call. I gave it a name, alpha, beta, and gamma. Okay. And we all know that some of the three angles is 180 degree, but that is none of our business right now. We are not worrying about it. And let's say the side opposite to this alpha is length small a. Side opposite to this angle beta is small b, and the side opposite to C, I mean this alpha, the gamma is C. So far I'm just giving names to everybody, okay? All the sides and angles we have given names. Yeah? And our goal is to find out whether the law of sine, which is sine of alpha divided by a equal to sine of beta divided by b is equal to sine of gamma divided by c. This is what we have to prove. Okay. So far you guys are not believing me. So now I have some task at hand. What I will do is from here, let me draw a perpendicular. and this is a point, let's say D. So now I have two triangles, two right angle triangles, ACD and triangle CDB, CBD or CDB, whatever you call it. Okay? Here in this triangle, let's look at what is sine of alpha. Sine of, I'm looking at this small triangle, okay? ACD. Sine of alpha, because this is a right angle triangle now, sine of alpha will be what? This length CD divided by, Sokatova says, opposite side divided by hypotenuse divided by B. Okay? So CD equals B of sine alpha. Now look at this triangle, this one, the bigger one. Here, what is sine of beta? Sine of beta is equal to same side opposite to this one, which is CD, divided by hypotenuse, which is A. So here you get CD equals A times sine of beta. So far okay? I did nothing fancy. I just took a triangle and gave a name alpha, beta and gamma, and we figured out which side is opposite to those angles. And then after that we picked up one of the vertex and dropped a perpendicular which is meeting at D. So that means it is splitting this triangle into two right angle triangles. We picked up this triangle so that we can pick up this angle alpha. What is sine of alpha? Side opposite to the angle divided by hypotenuse. So we got CD by B, this side B. And from this triangle we say what is sine of beta? Sine of beta equals the side opposite to that divided by A. So from this one we saw CD equals B of sine alpha, and from this one we got CD equal to A of sine alpha. So both are CD, so we can say B of sine alpha equals A of sine beta. Move the A and B, cross the border. B goes this side, becomes sine beta by B. A comes this side, becomes sine alpha by A. Yeah.
Wouldn't that lead to some complications though? Because then, if you divide by A, would it be B over A divided by plus sine A alpha over A?
So let's first come to
times, and then you have to divide, and that would be great because B. You have to divide by B over A, and then it would be sine beta A.
No. So I know you are thinking, and probably you are overthinking right now. But let's first get to what we were trying to achieve, and then we'll deliberate this. Okay. So now I'm moving. See, this is A times sine of beta. This is B times sine of alpha. So I'm moving A and B to other side. So A comes this side, becomes sine alpha by A. B comes this side, becomes sine beta by B. So from this one we got sine alpha divided by A. A comes this side, equal sine beta, B comes this side, sine beta divided by B. So I'll try answering your question, but up to this much whatever we have done, is it believable or not? Yeah. Now let me take your question. Yeah. What was your question now?
So like, if you have B sine alpha equals to A sine beta, and you divide by A, wouldn't that become that? So then that would be B over A times sine alpha over A, and then if you try to divide B, then you're dividing sine beta by B.
No, let's do whatever you are saying right now. Okay. So that otherwise I will get confused. Okay. I'm having little bit of hard time catching up in the calculation. Okay, so I have B. Okay, so if I keep sine alpha this side, okay, what will happen? A over B sine of beta. This is what
I'm saying. Like, no, it's like if you divide by and then but you can't only have the B on one side, can't you? You have to like put B on both sides, or
no. So see, this is the butterfly thing. So I had B times sine alpha equal to A times sine of beta. So I'm just moving this guy. So whatever is a multiplication here, it goes to other side, becomes a division. So it became A by B. Or I can say this as A times sine of beta divided by A. Okay. Now, so sine of alpha equals A times sine B. B times sine alpha, sorry, this is B. A times sine beta by B. So what I'm doing right now, I'm trying to keep sine beta by B, so I want to move A to other side. This is a multiplication here. When it comes to this side, it becomes sine alpha over A equals sine beta over B. As simple as that.
Okay, that makes sense.
Yeah. So it's always, I mean, I would not call it muscle memory. It's about how we visualize the whole calculation. When we had this thing, B times sine of alpha, what we are trying to get to is sine beta over something equal to sine alpha over something. A doesn't stand with this guy. I mean, with this. If I want to look at this equation this way, right? So I'm just moving A and B, both the constants, to opposite sides, so that multiplication becomes division, and then it matches with this one. Yeah. I hope I'm not complicating it for you guys. Praneet, Samriddhi, Dheera, are you guys with me or I'm getting you guys worried? So let me assume that we are all fine, and I will do that just to hide myself from you guys, so that I don't come across a difficult question. No, that is not the case. I love difficult questions. So there will be questions that I will know answer for, and there will be questions that I would not know the answer for. I have no shame in saying that, okay, I don't know this one right now, I'll figure it out. That's okay. So net what we did was, we picked up a triangle, we said these are angles alpha, beta, gamma, and then we said, okay, side opposite to alpha is A, side opposite to beta is B, side opposite to gamma is C, and small c, these are A, B, C are small, okay. And let me put PQR. PQR. And we draw the perpendicular from here, this is meeting at, let's say, S. So we got two triangles, PRS and triangle QRS. These are two right angle triangles that we got by dropping a perpendicular. Now in this triangle, let's say, okay, what is sine of alpha? Sine of alpha is side opposite to this one divided by B. So sine opposite to this is RS divided by hypotenuse. From this triangle, what is sine of beta? Sine of beta we got as side opposite to this, which is RS divided by hypotenuse, which is A. So from this one we got RS equals sine of alpha times B. Okay. And from this one we got RS equals A times sine of beta. So both RS are same. So sine of alpha times B equals A times sine of beta. So B times sine of alpha equals A times sine of beta. So we'll move A to other side, multiplication becomes division. So A comes here, it becomes sine alpha by A, and we move B to other side, it is multiplication here, becomes a division here, so it becomes sine of beta by B. That's all. So that's why I keep saying, okay, if I have multiplication, when I'm making it cross the equal to sign, this is how it goes below. So B comes this way and A comes this way. That's what you see here. Did you guys like my dance step? This one? Yeah? Okay. But Dheera likes the dance step? Okay. I hope this has more to do with the mathematical part of it. My dance steps are horrible. Don't focus on them. But I hope I was making sense here. Now same thing you could do by flipping the angles. So if you got two angles matching here, you can rotate the triangle and you can find the third angles ratio also. Here alpha and beta we picked. If you rotate this triangle and pick beta and gamma, that also gives you the same ratio. So I'm not doing the third one. That's the same thing. Is it convincing enough for us to move on to the next one? Praneet, Samriddhi, Dheera, everybody okay? Alright. So this is law of sine. So let's register this in our brain or even on the whiteboard that law of sine is a setup, is an arrangement for us so that we can relate the angles with the sides of any triangle. So even if you were thinking that okay, trigonometry meaning right angle triangle, no, keep it out. Any triangle, law of sine says sine of alpha by A equals sine of beta by B equals sine of gamma by C. And again remember one thing, this alpha and A, this is the angle and this is the opposite side. This is the angle, this is the opposite side opposite to that. This is the third angle and this is the side opposite to that. Okay? As long as you don't forget about the relationship between the angle and the side, you're fine. Now, this is law of sine. This is law of sine. Now there's an interesting one that is called law of cosine. And again, law of sine and law of cosine, these are the rules, these are the formulas or the methods, the theorems, whatever you call them, are applicable to any and every triangle. Okay? Now, what does law of cosine say? If you have, let's say, a triangle, let's say this is A and this is B. There are two sides that is known to you, and the angle between them, let's say this is theta. Okay, here, everybody here, everybody here. If you have a triangle where this side and this side, okay, are known to you, and this is the theta, this is the angle theta, then this side, third side C, is related to the other two sides of the angle, which says C square, the third side which is not known to you, is equal to A square plus B square minus 2AB times cos of theta. There is a relationship. So what it's saying is, if you know two of the sides and the angle between them, you can find the third side. In this case, if you relate it to this guy, you should know this side and this side. See, this angle is in between this one. Okay? Look at this one. Why do we even need to bother about cos of theta? As law of cosine. If you have law of sine, this works fine as long as you know the sides and one of the angle opposite to that side. In this case, what is happening? A and B are here and the angle is in between. If you want to use the law of sine, what will happen? Sine of A divided by this angle will be equal to sine of B divided, sine of this angle divided by A will be equal to sine of this angle divided by B. Now this angle and this angle both are known to you. How will you solve it in an equation? And when you have this angle, you don't know the side of that. So for using a sine, law of sine, you need a pair of side and angle known to you.
So you need two of both?
No, I'm saying you need one angle and one side pair known to you. Here, these two sides, their angles are not known. Instead, the third angle is known and the side is not known. So let's forget about this. Let's say this is alpha and this is beta and this is theta. Now, if you know law of sine, you will say, okay, fine. Let's see. Sine of alpha divided by, let me put the right name so that I don't confuse you guys. Sine of alpha divided by A equals sine of beta divided by B. You know A and B, so this part you know. But both angles are not known. So you have one equation with two variables. You cannot solve it. Am I making sense? If this was the angle given to us, then fine. This by this equal to sine of theta by this. So sine of theta, if you know the angle, you can find out the value by this. Then you can derive this angle. But the problem here is, both the things that is your coming from this relationship, both are unknown. So you will be stuck here. Yep.
So for laws of cosine, you only need the sides?
You need the sides and the angle between them.
Oh, okay.
So
and that would be cos theta.
Cos of that angle. So that's why it says law of cosine.
Okay.
So again, Dheera, Samriddhi and Praneeth and Sai. So why I'm stressing on why do we need law of cosine in the first place, right? It's just not about, okay, we know 5 things, let's learn 5 more things. Is that 5 more things that we're talking about, is that redundant or not? That's what we're trying to figure out here. If you know law of sine, you know you can, if let's say if you're looking at this combination, if you know side, 2 sides and one of the angle opposite to these 2 sides, then you can find the other one. If between these two, let's say if you know these 2 sides and one of the angle opposite to these sides, you're fine. You cannot apply it in this scenario because you know 2 sides and the angles opposite to that is not known. You only know the angle which is in between the sides. That is why it is an extra information which enables us to find out more things. Dheera, am I making sense, beta? Yeah? Samriddhi, Praneeth, are you guys with me? Okay. Now, another riddle to solve. I have given you guys one problem to figure out, okay, law of sine, and I said, okay, believe me, this is correct. And then I was forced to prove that because Praneeth said that you prove it, otherwise I'm not going to trust you. We have come across the same situation one more time. Yeah? Let's look at it. So, law of cosine says, I should reduce my font size a little bit. Otherwise, I'll have to buy another board. But it's okay. So, law of sine I'm not going to worry about right now. Let me delete that so that I have a little more real estate. So, law of cosine says, Sai, are you with me?
Hi.
Making sense to you so far? Okay. Now, law of cosine says c squared, c the third side which is not known to us, can be derived from the 2 sides which is known to us, which is going by this formula a squared plus b squared minus 2 times ab cos of theta. Yeah? So this is the law of cosine which I've still not been able to convince you guys that this is to be believed. Let's try proving it. Let's say this is a triangle, okay? Again, not a right angle triangle, okay? This time this is my A and this is my B and this is the theta known to us. We are trying to find out C. Okay? A and B are the 2 sides known to us and the angle between them. Okay? Everybody with me so far? I mean, at least you are able to visualize the triangle that I'm trying to do all the stuff with, right? Okay. Now, let's give it a name. P, Q, R. Okay? Let's drop a perpendicular from here to here again. And it meets at probably point S. So this length is B, this length is A. A and B are known to us, this theta is known to us, and this is the side which we are trying to see how it works. So now let's look at this triangle, okay? Let's look at this triangle. This small triangle P R S. This one. From this one, let's find out what is cos of theta. Cos of theta will be the side adjacent to this divided by hypotenuse. So let's say this length is here to here. Let's say this is x. Okay. So this length is x. So this equals, so cos of theta equals x divided by a. So far okay? Or x equals a cos theta. So we just took this triangle, this right angle triangle, because we dropped a perpendicular from here to here, and took this right angle triangle, from which we found out what is the cos of theta. Now let's look at this one, this triangle, okay? What does this triangle say? What does this triangle say? This is a right angle triangle. So from this one we can say, okay, this length is squared plus this length is squared equal to this length is squared. So c squared equals this length. This length is what? B minus x squared. This length squared plus r to b. R to b. This r to b. What did we say? No, we don't know this one. Okay. R to b. Sorry, R to S. We'll say RS. So this square plus this square equal to c square. So we are writing this c square equal to this square. This is what? B minus this length. So that is b minus x squared plus RS squared. Is that okay so far? Now let's look at what is the value of RS in terms of theta. Now we know this is angle theta. So RS by A will be equal to sine of theta. Yeah. So RS will be equal to A of sine theta. And you guys must be thinking that so much calculation, this old man has memorized it and is spitting it out. No, don't think it that way. I'm going to break it down for you guys to be able to absorb and process this. So we know R is equal to A sine theta from this one. So we'll just go on plugging in the value. We know value of x, this length is A of cos theta here, and we know this length is RS is A of sine theta. So we'll plug in those values here. So c squared equals b minus x squared. So b minus x is A cos theta squared plus RS is A sine theta. So RS squared will be A squared sine squared theta. Yeah. Am I doing okay so far? Okay. Now let's break it down. So it's A minus B whole square. B minus A cos theta. So this is A, this whole thing is B. So this will become B squared minus 2A times B cos theta plus A squared cos squared theta. This whole thing became this plus A squared sin squared theta. Now you see B squared minus 2AB cos theta plus here A square cos square theta plus A square sin square theta. So I will take A square common, it becomes cos square theta plus sin square theta. Cos square theta plus sin square theta is 1. Yes or no? So from this we found C square, this square equals B square, this one, plus this A square into cos square theta plus sin square theta became A square. So A square minus this thing 2AB cos theta. This was quite an earful. Yeah. So let's break it down. What did we do? We were trying to find out the relationship between cos of theta. I mean basically this law of cosine, which says if you know two sides and the angle between them, it goes by this relationship. The third side, square of the third side will be equal to square of the first side and the square of the second side minus 2 times AB times cos theta. We took this triangle, A and B are known. This theta, we just dropped a perpendicular from here to here. This became this right angle triangle, this is right angle triangle. From this one we found that okay, this is theta. We are talking about cos, law of cosine, right? So let's see what is cos of theta. Cos of theta will be this side divided by this. This is part of this whole thing. So we assume something for this time. Okay. So from that we found this x, this length is A times cos of theta. And then said okay fine. How about, okay, we'll come to this one later. So we found this length is A times cos of theta. Now we looked at this triangle. We don't know the angles and all. We don't know the angles. We only know this is a right angle triangle. So we applied the Pythagorean theorem, which says this square plus this square equal to this square. Now this part we know because whole thing minus this length is this part. That we can derive. But how about this guy? So that is why then we related this with the sine of theta. Okay? So to find this length, which became as RS divided by A equals sine theta. So we found RS equals A times sine theta. So now we know this length, and this is the one that we are trying to find out. So applying Pythagorean theorem, this square equals this square plus this square. This square will be square of this, and this will be this whole length minus this length. That's what we did. Complicated? Did you guys follow me okay, or it was quite a lot? And be honest with that, it's okay. Everybody clear? I will do it this, I'll probably prove it one more time, okay? I don't get lazy, but I don't get comfortable if I don't make it simple for you guys. Okay? That's my problem. You guys are fine. The teacher has a lot of psychological issues to deal with. Okay? Is it okay if I take 5 more minutes to just explain one more time? So, to prove this one, what did we do? We took a triangle, and this is the theta known to us. This is the side. These are the two sides known to us. This side is what we are trying to figure out or relate here. This is a triangle. We don't know the property. We just know this is a triangle and one angle. So we tried making it a right angle triangle. We made it a right angle triangle. We draw the perpendicular. So we split this triangle into two right angle triangles. We pick this right angle triangle. From this we said, okay, cos of theta will be equal to, let's say this is x, this is y. Cos of theta will be y over a. That means this length y equals a times cos theta. Okay, since we have put some x and y names, let's use this, find out this one also. X over a is sine of theta. So x over a equal to sine of theta. That means x equals a goes to this side, a sine of theta. So now we have found this x and y both. Now we are coming to this triangle. If we have to find out this triangle, we just know that this is a right angle triangle. No other thing is known to us. And this side is what we are trying to figure out. So we'll say that this is the hypotenuse. So c square equals this square plus this square. This side is how much? B minus y. B minus y with square plus x square. B minus y. Y is a cos theta, x is a sine theta. So you are just plugging the value. B minus y is a cos theta. Square of this plus x is nothing but a sine theta. So a sine theta is square of that. So this is a much cleaner thing, right? That's why I was trying to break it down. So this is b minus a cos theta whole square. That becomes b square minus 2ab. 2 times this. So 2ba or ab cos of theta plus square of this thing. So a square cos square theta. And this whole thing converts to a square sine square theta. Now, see, this is what we were trying to get to. A square plus b square minus 2ab. We found b square. We found 2ab cos theta. So these two are matching. Only this one is not matching so far. But here you see a square is common in both the terms. So this whole thing will become, this part only will become a square cos square theta plus sine square theta. This is equal to 1. So this became a square times 1. So the third term is this one. So now if you compare this, a square is this part, b square is this part, and minus 2ab cos theta is this part. Yeah? Everybody clear? Crystal clear? Okay. We don't have anybody with the name Crystal, but that was a dad joke. Bear with me. Crystal is not clear yet. Samriddhi, okay, beta? Dira, okay?
Yes.
Pranit, okay? So, who all have gotten used to my dad jokes and who are not?
What do you want us to do if we're used to them?
Huh?
What do you want us to do if we're used to them?
Then you have become tolerant. So then I will not have any guilt for cracking dad jokes. How about you, Dina?
Extra cost.
So far, how many dad jokes you have heard from me? Dina is opting not to say anything controversial. Huh? Okay, don't worry about it. My jokes are only meant for making sure that you guys feel comfortable. Okay. I mean, math is not a subject to bring in stress. I mean, I'm not getting stressed by math. I don't want you guys to get stressed either. So, we'll keep enjoying math. That's why the dad jokes are about us. Alright, so basically, whatever we have done so far, there are two rules or laws we learned. Laws of sine and laws of cosine. And you can relate it with this. Law of sine says alpha, beta, gamma. Now side opposite to alpha is A, side opposite to angle beta is B, and side opposite to gamma is C. So law of sine says sine of alpha divided by the side opposite to that, which is A, equals sine of beta divided by side opposite to that, which is B, equals sine of gamma divided by the side opposite to that, which is C. This is law of sine. And law of cosine says if you have any triangle where you have two sides known A and B and the angle between them, the third side is related to that such a way that C of square of C will be equal to square of A plus square of B, meaning the square of the two sides known to us, minus 2 times A into B times cos of the angle between the two sides. That was the story, and I am repeating this law of sine and cosine because we will not try proving these laws every now and then. Rather, whatever we have learned, we are inheriting these laws and will apply it for solving few problems. Okay? So now let me show you guys. So let's pick up few problems and see how we can apply it. Are you guys ready? And see, I have put 4-5 problems here. We will not try solving all of them, but we'll make sure that we have a very clear approach for solving them. First question says, there is a triangle ABC. ABC. This angle is given as 30 degrees. I'll ask you guys some interesting questions, okay? And you have to just tell me the approach. I don't want you guys to spend a lot of time solving it. So this question says, the figure shows triangle ABC. Man, what is going on here? Am I too old to remember things? I hope there is still some age left. Okay, so triangle ABC. This is the angle given to us, and these two sides are given to us. We have been asked to find out the length of measurement of C, this side.
Triangle C is obtuse.
Okay? We have been asked to find out this side. So, which law we will use? Now don't try solving it. Let's brainstorm. Okay? Tell me, Sahid. My question to you guys is, I have these two sides given to me and this angle given to me, and I have been asked to find out this length. Which law we will use? Here's the hack. Yes, Praneeth.
Cosine.
Law of cosine?
Yeah.
No.
Would it be law of sine?
See,
if
you
have to
will
find
use,
another angle?
again, remember this hack. You will use law of cosine when you have two sides and the angle between known to you. You have these two sides known to you and this angle. This is not in between these two sides. Rule it out. Yeah? And you will not use law of cosine till you get to figure out this angle. So, from this one, what you will do? You have these two sides known and one of the angle opposite to this side. Oh, you can simply apply, let's say this angle. So, this angle is opposite to this side, okay? So, now, let's say this is x. Sine of x divided by 37 will be equal to sine of 30 divided by 19. Yep. Sine of 30 we all know. Put that value, you can find out the value of sine of theta. And then from that you can find out what is the angle for which your sine of theta is that much, right? Using calculator. You have to use calculator, that's okay. Yep. So, once you know this angle, now see, you figured out this angle, you figured out this angle. Sorry, you have know this angle, you figured out this angle. You can find out this angle now. Yep.
It's 0.97 degrees.
0.97 degree.
Oh no, sine of that is 0.97.
So that will be closer to 90 degree, basically. A little less than 90 degree. So basically what I'm saying is, so from this situation, when you see the simple hack is, if you know two sides and the angle between them, you have no doubt about it. You'll apply law of cosine, find out the third side and then deal with it. If you have two sides and angle not having that relationship of being in between, you'll use law of cosine. Yeah, law of sine. Yeah.
How would you find like the exact angle from like just like sine of that equals to 0.97?
You can use sine inverse function
So
from there.
cosine?
I'm sorry?
Can't you just use cosine? Because it's the inverse of sine.
No, cosine is not inverse of sine.
Is it?
No, it is not. Sine of 45 degree equal to 1 by root 2. Sine of inverse 1 by root 2 will be 45 degree. That is what I mean by inverse function. Okay? Yep. Dita, Samriddhi, Pranit, am I making sense to you guys? Yeah? So basically, the hack is, if you know two sides and the angle between them, you'll use law of cosine. Otherwise, you will use law of sine. Because if the angle is not in between this one, that means it will be opposite to one of the sides. So when you have a side and an angle opposite to that known to you, law of sine is the best bet. Yeah? And then once you find this angle, then you can find out the third angle also. 180 minus this plus this. So you found this angle, you know this side, this angle, you know this angle, this side. Apply the law of sine again to find out the third side also. Yeah? Now let's look at one more problem, okay? But is this okay, guys? I mean, is it okay if you just look at it conceptually? I don't want to waste a lot of time solving this one because at least we'll see the application part of it. How to calculate, that is more to do with the calculation. Yeah? Is that okay? Now, let's look at, okay, this is an interesting one. This is an interesting one. We have nothing because the marker is not working. So we have, and I'm not saying this is right angle, okay? I'm not saying this is right angle. 8, 11 and 14. Okay? And we have to find out, let's say this is A, B, C. Okay? So you have a triangle given to you. Sides are 8, 11 and 14. And I'm saying this is not a right angle triangle. You can, because there is no information or confirmation given for that. We have been asked to find out what is the value of angle B. How will you find it out?
What does this say? 22 or question mark? Question mark.
Question mark. If I give you 22, what will you find? I'm saying you have a triangle where three sides are given to you and you have been asked to find out what is the angle. Dira, Samriddhi, Praneeth, any thoughts? Don't try solving it. I'm just trying to figure out how.
No, I'm just trying to test something. I want to see if my idea is right.
Okay. How this A part is helping us figure out how to do it. Read, analyze, and then do it. So I don't want you guys to do it, but read the problem. We have read the problem a couple of times. I'm just trying to get to this A part of the whole process. Samriddhi, Praneeth, Dheera, Davik, Sahit. If I have to give you guys $1 million clue, you guys can pay me $1 million once I'm 75 and when you guys are 45. Let me give it to you guys now. Are you guys not overthinking this? Yeah.
Okay, so I did sine inverse of 8 over 14. Sorry, yeah, 8 over 14. And then to test that, I did sine 34. And then it gave me a number, and then I did 8 over 14 to test that number, and it was like roughly the same, because I rounded it up, so I got it right.
Okay. Any other idea? Samriddhi, Praneeth, Dheera? And today you guys will realize how simple your teacher is. Yes, Samriddhi, go ahead.
I'm not really sure.
But you guys remember what we did today, right? We did law of sine and law of cosine and what is the relevance of those, right? Now you guys will see my simplicity today. Law of cosine. Then when you are analyzing this one, law of cosine says if you know two sides and the angle between them, you can find the third side. Can I think it reverse, that if I know two sides and what I have to find, I can derive this one? Look at this formula again. See, there is nothing fancy about it. If this is theta, this side opposite of the theta, 8 square will be equal to square of this plus square of this minus 2 times this into this times cos of theta. Isn't this the cos of theta? So you know this, these are constants. You can derive cos of theta.
Oh, so you just divide by all of that stuff?
No, I mean not divide by, I'm just calculating.
Not plus 14 and 11.
64, this is 14, 4 are, I think 196. 14, 11 is 121. Minus 2 times 11 is 22 times 14. 22 times 14 is 308 times cos of theta.
And then you just get all of the other stuff to the other side.
Yeah. So you get cos of theta from here. This whole, okay, let's do the calculation. 64 equals, or 64 this side and this whole thing comes this side. So 308.
So negative cos theta.
No. 308 cos theta comes this side, becomes positive. Equals 196 plus 121 is 197 plus 20.
2, 3, 317, I think.
Okay, let me not rely on my mental maths. 6 plus 1 7, 9 plus 2 11, 1 plus 1 2 plus 3 317. Yeah.
Yeah, I was just saying 317.
317 minus 67 gives you 250.
Wouldn't it be 64?
No, sorry, my bad. 64, so this is 253. 380 cos theta equals this, so cos of theta equals 253 divided by 308. Yeah, close to 0.6, 0.7. We are essentially talking about angle being somewhere around 30s, 32, 34. Yeah? Or whatever it be. Let me not know.
I had a 1% margin of error.
So again, see, there's nothing fancy about it. These laws of sines and cosines are meant for us to be able to relate the sides and the angles. Now it is our choice that we have to make based on the information we have. If we have to find out the angle, see again, same hack. Oh, I had two sides and the angle between them and the third side. If I knew this angle, I could derive this one. Now everything is known to me except this angle. Can we just apply this formula and see what is this coming to? Yeah? Is it making sense, Samriddhi, Dheera, Praneet? And I took a very simple route. Very simple route. He said, okay, fine. I know two sides and the angle between them is what we have to find out. But the opposite side is known. Let's just plug in that into the law of sine and see if that gives us a clue. Yeah? So that was all about law of sine and cosine. We solved some problems. We just looked at how do we approach these problems. And these problems are no-brainers, okay? These are straightforward ones. Provided you just need to read the question a couple of times and visualize this. This scratch work, okay? This scratch work is very, very important, okay? When you, and now if you see, right, what I keep bragging about, this phase of the whole workflow tells you which rule you would apply. You have two options, law of sine, law of cosine. And see, if you use law of sine, for law of sine, if you know two sides, you need at least one of the angles so that you can find out the other angle. Here there's only one angle that you have to figure out. It might not be a great idea. So during your analysis, you know that okay, if I have any triangle, only sides or angles we have to figure out. I have two options, law of sine, law of cosine. Which one will fit the bill here? And that is where this stage of your juggle will make it clear. Alright? With that being said, I will let you guys go, and we could not come to the constraints of the inverse functions, but we'll cover that in the next class. Don't worry about it. That should not take more than 15 minutes, okay? Just that we did not have time, so we could not cover that. Alright? Yep. Dheera, Praneet, Samriddhi, all okay?
Yeah.
I think I scared Tony enough. She dropped off, but I hope she watches the video of the class to catch up, and then we'll take care of it. Alright? See you guys in the next class.
Nice.
Bye-bye. Good night.